If you're looking for a content explaining what is KubeArmor and how to configure it, then this episode is for you. Welcome back to the Is It Observable YouTube channel. Today's episode is going to be part of the security playlist where I covered a couple of episodes. We recently explained what is Falco and what is Tetragon, how we can configure them, and what type of observability data we can get out of these agents. But today's episode is going to be similar to this series, but it would be related to another runtime agents also relying on eBPF, and I'm referring to KubeArmor. If you enjoyed today's episode, don't forget to like and subscribe to the channel. So let's see what you're going to learn from this episode. As usual, we'll start by presenting the KubeArmor project, what we'll have in the one we deploy, a few aspects related to it, and then we will describe the CRD helping us to define policies in our environment. You'll see that there is a specific one for the host, specific one for the cluster, and one for our deployments. And last, we will understand how can we extend our observability using KubeArmor. Similar to the other agents of the market, KubeArmor relies on eBPF to detect suspicious events in our cluster. In fact, KubeArmor leverages Linux security modules, so LSMs, such as AppArmor, SELinux, or BPF-LSM to enforce our cluster depending, of course, on the policies that we may have defined in our cluster. Similar to the Tetragon project, KubeArmor will report observability by pushing events on the process level, on the file level, network, or capability usage. This, of course, has to be enabled. Before jumping into the details on the KubeArmor events and how to enable them, let's have a look at what you will get when deploying KubeArmor. So first, you'll have the core components that all the security agents are relying on. It's the daemon set that will deploy the BPF probes in our cluster. This is the most important component because at the end of the day, it is responsible for reporting the events and applying the right enforcements. Then you will have one of the important elements of KubeArmor, which is the operator. It's a Kubernetes deployment that is allowing us to enable or disable KubeArmor events based on annotations and configure our policies. The configuration of the policies is done with the new CRD introduced by KubeArmor. So we have the KubeArmor policy, but again, there are several ones. We'll touch base on them later. Then you have the actual controller deployment. Not really sure about what it's doing, but I guess it has a role to spread the configuration into the BPF probes running in our cluster. Last, we have another deployment, which is the KubeArmor relay. So it looks pretty interesting because the agents of KubeArmor are not exposing any events in the logs of the pods. So that was my first surprise when I looked at KubeArmor. So the events at the end of the day will be available in the relay. It seems that the agents are exposing the events through an gRPC endpoint. So the relay server will pull the events of the agents using the gRPC protocol. And then the relay server is the component responsible to share the output of those events in various protocols. So it means that if you want to collect the events using a log agents, then it means that we need to modify the settings of the relay server to explicitly generate those events, those alerts, into std out. So it will be turned off by default, and I guess it's turned off for performance reasons. But that is one of the points that makes the observability journey of KubeArmor more complicated compared to the other agents of the market. Like explained, those events would only be produced if they are turned on. So to enable the visibility, we simply need to add the right annotations to the target component of Kubernetes. So the annotation is KubeArmor visibility, and the value could be a list of dimensions that we would like to enable. So it could be, for example, KubeArmor visibility file, network, process, capabilities, if you want to enable the events related to the file usage, network, processes, and capabilities. This annotation can be placed in various areas of the cluster. So at the pod level, I may place it on the template specs of our deployments, but still it sounds a bit strange to limit the visibility on a given set of pods. The other options that makes a bit more sense is to have it at the namespace level, and last we have also at the node level. On the node and namespace level, it sounds interesting to control at least the volumes produced from our cluster. So let's have a look at the structure of those events. So here is an example of a process event. So it returns the process executed, the parent process as well, similar to Tetragon, the Kubernetes metadata, and the type of system call. So here is a network event. So it's the operations, the data, and the resource fields that will provide different details based on the type of events. Operation is the field defining the source. So it could be equal to process, file, network, and so on. So here is an example of a file event. That is the default structure of the events, but when building policies, you will have the similar information, but you will also have another field called action fields added that will help you to understand if it's an alert or a simple event that has been blocked by KubeArmor. So action could be equal to blocked or audit. It also adds an enforcement field to let you know which type of solution was in charge of this detection. So BPF-LSM, eBPF monitoring, and so on. The other interesting part is to define a default behavior on the policy. So we could have, for example, a policy that allows us to detect specific events, but let's say in a given namespace, there's a default namespace, for example, we want to make sure that this event is blocked. So then the event will be blocked, and in the other namespace, it won't be blocked. There are three annotations available. So we have KubeArmor file posture, we have KubeArmor network posture, and KubeArmor capabilities posture. That will be, of course, equal to audit, just to be notified, or block. These annotations could be placed at the namespace level, but there is also a default posture for KubeArmor in general. This could be defined when configuring the operator using a specific CRD called the KubeArmor config. So here's an example of the KubeArmor config CRD. As you can understand, KubeArmor will throw events related to the usage of the file, the processes, the network. Of course, they need to be enabled. But if you want, you can build alerts to reduce the quantity of events, or moreover, alerts that will block specific behaviors. Then for this, you will need to configure a KubeArmor policy. There are various CRD helping us to configure the policies. So technically it's going to be the same type of configuration, but it will target different type of Kubernetes objects. So you have the KubeArmor policy that will target deployments in a given namespace. Then you have KubeArmor cluster policy that will target the entire cluster. And last, we have KubeArmor host policy that is designed to target a specific node of a cluster. I personally have used only the KubeArmor policy and the KubeArmor cluster policy, but the host is interesting if you have various type of hosts handling different type of kernel, and so at the end, the different type of syscalls. So let's have a look at the actual definition of these policy objects. So here is the default definition. So all the policy will have the similar structure. So you have a name, of course, then you can assign details related to the alert itself. So a message, a customized message, a tag, a severity, and that will be reported in the events, the alert event, I would say. Then the object has a notion of selector to limit or filter specific workload in the case of a KubeArmor policy, or namespace selector in the case of a cluster policy. Last, it has an actual field defining what KubeArmor should do with this type of event. Should it block or simply alert? So basically block to block and audit to alert. Then in the policy, you will define the type of events that we're targeting. There are several targets. So there's process, file, network, capability, and last, syscalls. Each of those sections will precise the type of file path or process or networking actions or syscalls that we would like to be alerted on. Of course, each individual sections will have their own type of settings. So here is the configuration for the processes. You can see you can match on the source, on the path. There's different way of filtering your events. So here are the configuration related to the file, where we can match on the given path or directory that we're targeting, or the type of process that is trying to reach out to this given file. So here are the settings for the network, where we can limit on specific protocols and the communication patterns. I thought that the networking is a bit difficult to define, to have the right filtering, specifically if you want to do from source to destinations. We have, of course, capabilities where you can filter on the capability huge, and syscalls, of course, to configure the type of syscalls that we would be interested in this event. Even if it has a variety of settings, it requires a good level of expertise before starting to configure those policies. I would suggest, if you're new to KubeArmor, to turn on the events, so the file, the network, whatever the events that is available in KubeArmor, and then based on the events that you have observed, you can list the type of processes, the type of files that are used, and then you will be able to configure precisely the policies. KubeArmor does not provide out-of-the-box policies for common vulnerable events, but it has a repository with many, and maybe too many policies. So small message to the KubeArmor policy, it will be great to have a sort of website helping us to filter and find the right policies. So here is the link to the repo with all the various policies available. KubeArmor has a CLI allowing you to interact with the operator. I'm not a big fan personally of CLI. The CLI, by the way, has a command KubeArmor logs to look at the event produced by KubeArmor without having the need to turn on the std out options in the relay server. But more interesting than just the log commands, it has an action called recommend. So you could basically launch KubeArmor recommend on a given namespace, and it will provide the policy that we need to deploy in a given namespace. I would love, honestly, to have this type of feature available, a bit similar like a VPA settings, where we can define the VPA settings as a recommendation mode to basically give us advices on the resource request and limits usage that we need to apply on the pod. And by the way, if you're interested in to have more details on the VPA, to scaling, check out the episode related to it. But to come back to KubeArmor, I think it would be great if they had like a sort of CRD that we deploy, and the CRD will generate as an output of the object itself the various policy that we may need to apply, and maybe where we can find them if they are not available directly in the operator. On the observability side, we have lots of things to say. So first, yes, like all the security agents, the data produced is designed to help you extend the level of your observability. But it requires some settings to enable first the logging properly and get the agents to collect those logs. So one interesting thing that I discovered is that the KubeArmor community has worked on an open telemetry collector receiver to get the KubeArmor events. It is a great initiative because you won't have to enable the std out settings anymore. So here is the repo related to this receiver. The only downside is that the receiver is living in the KubeArmor organization and not in the OpenTelemetry contrib repo. So please submit it upstream so everyone could take advantage with the default contrib versions of the collector. Yes, of course, OpenTelemetry contrib repo contrib collector is not recommended, but at least it's easier to try it out. I will try later on to use the OpenTelemetry Collector Builder, so OCB, to build the right collector release with this receiver and try it out. So far, I didn't have the time to build this collector with this given receiver, with all the plugins that I need to collect and parse whatever the data that go through the collector, but I promise I will do it in the tutorial repo. Then KubeArmor has worked on a project called Psychic. It reminds me about Falco, to be honest. So similar to the traditional Falco Psychic project, it is designed to collect the alerts retrieved by Falco and push them to several solutions of the market. So it could be like a chat message like Slack, Teams, or observability solutions. So here is the repo for this Psychic project. But honestly, I think that this project is not super useful. I mean, once the std out settings is configured properly, the event produced in the log is pretty much easy to parse because it's super structured compared to other products of the market. So if you look at Falco or Tetragon, they are providing more fields and more details depending on the type of events. So the way you need to parse your logs on Falco or on Tetragon, it really depends on the type of events. So it complicates your parsing journey. But in KubeArmor, it is super structured. So any log agents of the market, so the collector, Fluentbit, or any others, could easily parse those events with a common role and not 5 or 6 different roles. Last, KubeArmor has a default Prometheus exporter available, but when deploying KubeArmor, we have a service named KubeArmor Controller Metrics Service. So honestly, naturally, I've tried to connect to that service and to try to scrape the metrics from there, but it requires a specific TLS settings. So if you were successful to collect those metrics from this endpoint, please drop a comment below. And otherwise, there's nothing related to that service in the documentation, so it would be great to explain what's the purpose of that service and how we could actually utilize that service properly. Otherwise, in the KubeArmor repo, there is a project providing a Prometheus exporter that will expose metrics. Again, these projects will connect to the KubeArmor agents through the gRPC interface, and similar to the relay server, it will produce metrics out of the alerts, not the events, only the alerts. Because the relay server seems to do the same, I guess it would make more sense to connect it to the relay server to reduce the pressure that we may put on those agents. So here is the link to the Prometheus exporter repo. The metrics exposed in this exporter is not adding any extra details than the one available already in the logs. In fact, not only on the logs, only on the alerts, because it only covers the alerting. So if you collect already logs, the metrics would have a really limited value, except to reduce the quantity of data that you need to ingest. Again, I think if you're dealing with the logs, I really wonder what's the value of this project. And I think this project is a bit deprecated, so I don't think it's going to be used in the future. So one disappointing thing is I did not find any metrics or data that could help us to measure the health of KubeArmor agents or operator. So this is clearly missing. So please, KubeArmor community, it will be very welcome to have that type of details to manage KubeArmor in our environments. Yes, we want to report the security events for sure, but then we're going to manage these solutions in our cluster and daily day-to-day production activities. So we want to make sure that KubeArmor is running smoothly in this cluster. So please provide that type of metrics. Tetragon is doing it, Falco is doing it, so please do it as well. That's it for today's episode related to KubeArmor. So another solution, security runtime agents relying on eBPF. I think it is quite interesting the way you can control the events produced from KubeArmor. So I think by default they won't produce any events, so you will have to turn it on. So and again, I think the way of doing it through annotation is quite smart to control which namespace you're interested, which host you're interested, which workload is interested, to avoid having tons of events generated everywhere. And I think, again, you don't turn it on everywhere, you turn it on to understand the structure of the actual events and things happening. And that type of source will be useful to then configure the KubeArmor policy and cluster policies and other policies available through KubeArmor. I like also the fact, what is interesting also that I didn't find in any other project, is the ability to create a rule and then a default behavior. And then if you, for example, you have a given namespace where this rule needs to be very strict, then you can force to say, okay, even if it's allowed or even if it's audit, please block that, because at the end, because we are very sensitive namespace. So I think this is an interesting feature that I didn't see in the other project. So again, that is really cool. Maybe the other project is doing it a different way, but I think the annotation is quite smart. On the observability side, again, if you turn on events, if you get the alerts, you get the details that you need from a logging perspective. And I think being forced to turn on everything from a log perspective on the relay server complicates a bit the settings. So if you're new to KubeArmor, you need to be aware of this. And then one big downside, to be honest, is the lack of metrics. I think just metrics about the policies deployed, the one that has been, I don't know, rejected or not loaded properly in the environment, or even just the couple of indicators about the health of KubeArmor. For example, that there's no capacity anymore, there's no cache, I don't know. Anything that will help us to drive and be alerted and react if KubeArmor is suddenly completely saturated. Again, this could be done easily by the community, so I'm really, I think that in the future this will be resolved, but that is currently my feedback after looking at the project. Alright, so if you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode. Bye.